Hello guys, how are you today? So today I'll be explaining topic 3, water. So I'm gonna be reading and trying to explain what I understand, and as well I will solve the questions, which are the CQDs. Okay, we start with the first sentence, which states that water is the most abundant substance on the surface of our planet and is essential for all living organisms. This is very important. It literally just summarizes why we need water in life. Okay. And then later on in the topic, we're gonna be discussing how do we purify water, how do we why water is important for the living things, and etc. So they said implication of inadequate supply of water. So what happens um, if there is an unavailability of fresh water? If the water that is surrounding is not fresh, there may be some waterborne disease such as cholera and typhoid. These are very dangerous diseases. They affect human health and might even lead to death at some point. Then we have diarrhea, one of the biggest killers across the world. This also is caused because of unavailability of fresh water. Actually, one of the ways to overcome diarrhea is to drink water, because when you have diarrhea, you're having a loss of water in whatever you excrete. So the loss of water is going to affect you, and this will at some point kill you. Of course, not you, but just if it happens to someone, it will kill them. And to prevent the killing, you have to drink water, so you will constantly supply your water, and you will not have water loss. Okay, and then we move on to famine. Agriculture needs a water supply in order to irrigate crops. In many places in the world, there is the issue of famine because not only fresh water, but just water in general is not available. And this is just a reminder to be thankful for whatever we have. And really, these are very dangerous things that could happen if there is no fresh water available. Now we move on to natural water. Where can we get natural water? Actually, you can get natural water from everywhere. Wherever you look, you can find water. But some of these water contain substances, okay? Some of the substances, they are dissolved oxygen, metal compounds, plastic, sewage, harmful microbes, nitrates from fertilizers, and phosphates from fertilizers and detergents. Now, some of these substances are beneficial to living organisms, like dissolved oxygen for aquatic life. Dissolved oxygen allows for example, fish and anything that lives in the water to use the oxygen. Because as you know, the fish live in the water and they also need oxygen to survive. So the oxygen will dissolve in the water, and that is how the fish will get their oxygen. Now, the metal compounds, it's very useful, and at the same time, it could be beneficial. It's useful because it gives minerals that will sustain life. Okay? However, they could be toxic. So they are minerals, or they could even be toxic. So dissolved oxygen and metal compounds are both essential and beneficial to aquatic life, or just in general they are beneficial. However, metal compounds and everything under is toxic. So metal compounds is an intersection of both beneficial and harmful. But we know that dissolved oxygen, it is beneficial for fish. Metal compounds is beneficial for minerals, but it could also be toxic. We move on to plastics. Plastics, they cause harm to aquatic life, and we know this to be very widespread around the world. Save the turtles. You see some turtles getting caught in plastic. You see some fish they're getting tangled in the plastic. So it's just something really sad. So we say plastics are harmful to aquatic life. We move on to sewage. Sewage and harmful microbes are kind of related, because sewage will give us these harmful microbes, okay? You can put them together. I don't know how to draw it. I will just draw it like this. So sewage will give us the harmful microbes, and the harmful microbes might cause diseases. Okay? Now, nitrates from fertilizers and phosphates from fertilizers and detergents, they lead to the same thing, which is the deoxygenation of water. So let us write it, deoxygenation of water, in addition to harm to the aquatic life. Now, how do the phosphates and nitrates cause the oxygenation of water? First of all, they will do something called eutrophication, which is the growth of algae, or the excess growth of algae. And what happens is that nitrates and phosphates from fertilizers, they're used to grow the plants, and algae, they are a type of plant. So when they go into a body of water, they will eventually cause the algae to multiply so much to the point where they will cover the whole surface, and it will be like impossible for the plants that are beneath under the algae to grow and reach the sunlight. This first thing causes the death of some plants. After that, there will be a competition between the algae to reach the sunlight, to use up the minerals, etc., to use up even the oxygen. And this will cause, because of the competition, the algae will eventually die. Yeah? And when they die, what is the role of the decomposers? The role of the decomposers is to break down these dead organisms, or these like dead organic organisms. I don't know what to call it. Yeah, so they will break down these dead things, these dead old living things. Sorry, that didn't make sense, but you understand what I mean. They will break down the dead algae, and in the process of breaking down the algae, they need oxygen, so that's going to be an extra use of oxygen. And because of the amount of algae and the amount of decomposers decomposing the dead algae, this is going to cause to the deoxygenation of water. There will be a point where there's no more oxygen in the water, and this will lead to killing the aquatic life, especially the fish and like any like animal in the body of water. Okay, we move on to over here. Further sources of pollution include acid rain. Acid rain is caused by the mixture of sulfur dioxide and nitrogen, like the oxides of sulfur and nitrogen, with the air, or like with the water in the air, and then it will fall down as acid rain. And then power stations which generate electricity consume huge amounts of water for cooling purposes. When water is returned to rivers or lakes, it will be hotter, decreasing oxygen solubility. Aquatic life suffers as a result of lesser oxygen. So yeah, that's pretty much it for the natural water. So we have CQD number 1. Now here, I don't know if they mentioned it above. I don't think they did mention it above. But you need to know that natural phenomena that can cause water pollution. We have two natural phenomena that can cause water pollution. So natural phenomena that can cause water pollution, we have two. They are volcanoes and lightning. Okay? Now, for example, the acid rain that we discussed above, this is not a natural phenomenon that causes water pollution, because the acid rain, it is becoming acid because of the sulfur and nitrogen oxides being released by factories. So this is definitely not a natural phenomenon. Whereas volcanoes, okay, and lightning, they are the natural phenomena that can cause water pollution. We move on to CQD number 2, which is a grid. They said, name the major water pollutants and classify them as organic and inorganic. Organic and inorganic is different from natural and unnatural. Natural means it happens by nature, okay? Unnatural means there is human intervention in the process. Whereas organic and inorganic, that means it's made out of purely natural things, okay? But like humans made it, of course, so definitely this is human intervention. It's unnatural, but it's organic. And inorganic, meaning there is some chemicals added to it. It's not made fully of organic materials. So like both organic and inorganic are unnatural things, but organic is made out of the natural things taken from nature, and with human intervention they are made. And then inorganic, with human intervention and with some things from nature and some chemicals, they will make it. Okay, So, organic pollutant, we have three major organic pollutants. They are pesticides, and then they are detergents, and then they are sewage. So for the organic, keep in mind that we have three main types of organic water pollutants. They are pesticides, detergents, and sewage. Whereas for the inorganic, we have only two types. One of them is fertilizers, and the other is heavy metals. Okay, it could be heavy metals or heavy metal ions, same thing. So, organic major water pollutants, pesticides, detergents, sewage. Inorganic major water pollutants, fertilizers, and heavy metals. So now we move on to CQD number 8. I believe they gave us the table below. Now we will look at it. So water from natural resources may contain beneficial and harmful substances. Fill the table to list these substances as beneficial and partially. I don't think partially, I think they mean potentially. So that's incorrect. It's not partially harmful, it's potentially harmful. It is harmful. Okay, so they filled the table for us. Let us just read and understand what they're saying. Dissolved oxygen, it is beneficial for aquatic life. It lets the aquatic life use the oxygen for their processes. Metal compounds. Some metal compounds provide essential minerals for life, whereas some are very toxic. Okay, this is very important to know. Sewage, which gives us harmful microbes. The sewage contains harmful microbes, which causes disease. Okay, and then nitrates and phosphates from fertilizers. Nitrates and phosphates lead to deoxygenation of water, as we discussed during eutrophication, and then damage to aquatic life. And finally, plastics. Some plastics harm aquatic life, like for example, the turtle getting tangled in plastic or thinking that plastic is jellyfish and it will try to eat it. So now we move on to water treatment. Steps involved in water treatment are sedimentation, filtration, and screening to remove solids, sterilization to kill microbes, and removal of tastes and odors by using carbon. Okay, so before treatment, water has both soluble and insoluble impurities. It is made safe to drink by removing the solid impurities and killing bacteria. So, the solid impurities like soil, plant parts, organic matter, whatever, are removed by sedimentation and filtration. Water is stored undisturbed, so the solids settle at the bottom. This is sedimentation. The water is then passed through stone and sand filter beds to remove any solid impurities that escaped sedimentation. After that, to purify the water to kill the microbes, we add chlorine. Chlorine is bubbled through the water to kill the bacteria, and then the safe, clear water is pumped through underground pipes to houses. In addition to chlorine, other methods can be used to sterilize the water. These methods include ultraviolet light, adding ozone. The addition of ozone kills the bacteria easily and can also attack some of the organic matter responsible for the bad smell of water. Ozone is a highly poisonous gas, so care has to be taken when adding it. So in CQD number 3, they said briefly state how water is treated. Okay, so if I could go down and I could make a small diagram at the bottom. So we first start with storage or sedimentation. Storage, aka sedimentation. Okay, after that, we will move on to filtration and screening. Filtration and screening. Then after that, we will move on to aeration. This is all taken from the answer key, by the way. And then we will move on to sterilization. Okay? So what do we need to know about each part? Okay, we first start off with storage or sedimentation. We store the water so that the insoluble impurities will settle all the way to the bottom. Okay, this is called sedimentation. They will form sediments and then you can collect them. After that, you will move on to the process of filtration and screening. For filtration and screening, you will remove the solid insoluble impurities. Okay, then for aeration, I believe this is probably the addition of carbon, okay, to make the taste cleaner, okay, or to remove like the weird taste from water. And then finally sterilization, which is the removal of bacteria by adding chlorine or the ultraviolet light or the ozone, and you will kill the bacteria. So first stage, it is sedimentation or storage stage. You will store the water, okay, and then it will form sediments, which will be removed by filtration and screening. Then we move on to filtration and screening. You will remove solid insoluble impurities as well as the soluble impurities, but the soluble impurities will remove them later. Okay, so the filtration and screening is mainly used for the removal of solid insoluble impurities. Then we move on to aeration, which I believe, I'm not sure because the answer key did not provide too much detail about it, but I believe here they mean by the addition of the carbon so that they will make the taste of water clearer, even though that should be later on. But memorize it in this order. This is how it came in the answer key. And then finally, sterilization, which is the addition of chlorine or ultraviolet light or ozone to kill the bacteria. That's CQD number 3, done. We move on to CQD number 4. They said polluted water is treated through a process of several purification steps in order to be used for domestic purposes. The following schematic diagram represents the water treatment process. Okay, so as you go down, you can see that we have water plus bacteria plus large solids plus fine solids, then water plus bacteria plus fine solids, then water, bacteria, and then pure water. So they told us at which stage is screening performed. First of all, what is screening? Screening is the elimination of large insoluble solids. So definitely, if we're moving from here until here, there's no more large solids. So definitely, A, it is gonna be screening. To explain, you can say that large insoluble solids are eliminated. We move on to part B. They asked us at which stage filtration is performed. Filtration is the elimination of small insoluble solids using a very fine sand to filter out the fine solids. So very simply, as we're moving from here to here, we got rid of the fine solids. So that means that B is the stage at which filtration is performed. And to explain, you can say that small insoluble solids are eliminated using a very fine sand to filter out the fine solids. We move on to part C. In part C, they said specify between which two steps sedimentation should be performed. Now, sedimentation is when you store the water full of soluble and insoluble impurities, and it will cause mainly the fine solids to become sedimented. It will be easier to remove them using filtration. So what you should know is that sedimentation usually occurs at this stage over here, in between what? In between screening and filtration, in order to cause the fine solids to sediment. So if you were to specify your answer, you would say between screening and filtration. Okay? Now, for part D, they said, what do we call the last stage, which is stage C? As you can see, in stage C, we had bacteria. Before and after, it was pure water. So the killing or removal of bacteria is called sterilization. Another naming could be, for example, chlorination, or whatever you use. It could be chlorine, ultraviolet light, or ozone. It's used to kill the bacteria. But the last stage, stage C, is called sterilization. What is used to eliminate odor and taste of water? So, to eliminate the odor and taste of water, we said it is carbon. So at which stage is it added? It is added usually before stage C or before screening and filtration. So before screening. No, sorry, not screening. Before sterilization, my bad. Sterilization. Okay, so to eliminate the odor and taste of water, we use carbon. I believe this process is called aeration. Okay, and then before the sterilization, what occurs? Aeration occurs, which is the addition of carbon to eliminate odor and taste of water. And then finally, after that, you have aeration. Okay, now we move on to CQD number 11 top. Polluted water undergoes many steps in a water treatment before it becomes suitable for drinking. Which step is the steps used to remove insoluble impurities from polluted water? So, insoluble impurities from polluted water. Here we have two main steps. It's either the screening, okay, or filtration. So you look in the answer if you have screening or filtration. As you can see, you have filtration, this could be an option. Coagulation, we didn't discuss the addition of chlorine because the addition of chlorine happens in sterilization. Aeration, no, none of the above, no. So the answer is A, filtration. Okay, we move on to this. Removing tastes and odors from water is an important step in water treatment. This is usually done by aeration. Water is mixed with air. Any volatile impurities responsible for odors are released. And then filtration through activated carbons removes taste and odors. Okay, so as you can see, I was mistaken. The aeration is the addition of air to remove the odors, whereas during filtration you add carbon and this removes tastes and odors. Okay, so carbon is separate from aeration. All right, the addition of carbon is during the filtration, and aeration is just the addition of air to remove any responsible odors. Now we move on to CQD number 5. They said, what substance can be used to remove tastes and odors in the treatment of water? Very simply, we know that it is carbon. If you add carbon, you can remove the tastes and odors in the treatment of water. We move on to this text over here. Some countries add sodium chloride and AF to the water to reduce the tooth decay. This is not highly recommended because it leads to the appearance of permanent black lines in the teeth. Okay, test for the presence of water. A hydrated substance is one that's chemically combined with the water, while an anhydrous substance is one containing no water. So remember, hydrated has water, it's chemically combined with water, whereas anhydrous, okay, it does not contain any water. The term of crystallization refers to the water molecules present in hydrated crystals. Of the anhydrous salts, two are very useful to indicate the presence of water: anhydrous copper disulfate and anhydrous cobalt dichloride. So what you need to remember is here, using anhydrous copper sulfate, water turns white, anhydrous sulfate blue. So when the anhydrous substance, which is copper disulfate, which is white, is added to water, it will chemically combine to water to produce a blue substance. Okay? Same thing with the cobalt dichloride. When cobalt dichloride, which is originally blue, it will react with water, it will chemically combine to produce something that is pink. Alright, so just keep these in mind. So anhydrous copper sulfate goes from white to blue, whereas anhydrous cobalt chloride goes from blue to pink. We move on to CQD number 6. They want us to fill in the blanks, okay? When a few drops of water are added to anhydrous copper sulfate, we know that anhydrous copper sulfate will go from white to blue, okay? When a few drops of water are added to anhydrous cobalt chloride, we know that cobalt chloride will turn from blue to pink. So like, just keep them in mind. They're not that difficult. It's very easy. So now, test for water purity. How do we test for water purity? It always is by the boiling points. Actually, to test if any substance is pure, we test its boiling and melting point. And we know that liquid water will boil at 100 degrees Celsius and it will melt at 0. And the ice will melt at 0 degrees Celsius, okay? Now, pure water can only be produced by distillation. To get pure water, it's only produced by distillation. It's not good to drink distilled water. Why? Because when we drink water, it is a source of ions for the body. And if you don't have the ions that are found in the water, Okay, health problems may arise. So pure water, when we're drinking, it's not pure water. It is more like just something pure. That's why some of the water we drink, it has minerals. So some of the minerals, for example, we have calcium, we have magnesium, we have sodium, we have potassium, we have iron, we have chlorine, we have fluorine, we have I don't know, we just have a lot of ions. And these ions, without them, like if they are not found in the water, we may have some health issues. However, we do use the pure water in practical chemistry, especially in labs, because it contains fewer chemical impurities. So it does not have any chemical impurities. You'll use it as just like something pure to experiment with. We move on to CQD number 7. How many types of water are there? There are actually 3 main types, okay? What are these 3 types? We have water from natural sources, or you can say natural water. Then you have distilled water, which is the pure water. And then you have the domestic water, which is the water that is purified and then sent to domestic places like a house or a school or hospital or whatever. For part B, describe how to test the purity of water. To test the purity of water, okay, we will check its melting point, so MP, and boiling point, BP. We know that water will melt, like if it's ice, it will melt at 0 degrees Celsius if it's pure, and liquid water will boil at 100 degrees Celsius if it is pure. Okay, now for part C, why is distilled water used in laboratory experiments rather than tap water? We use distilled water because it contains less chemical impurities than tap water. So I believe that is it for this topic. Thank you guys for watching. I hope you enjoyed and have a wonderful day.